Hey, I'm Jocelyn Matthews. I am the community manager at Storj Labs. And with me today, I have JT Olio. JT is our vice president of engineering. And the topic today is going to be end-to-end encryption, what developers need to know. So first off, JT, how are you doing today?
Good. I'm glad to be here.
Great. End-to-end encryption is something that a lot of people are thinking about and talking about right now. And it has actually some pretty specific definitions. So I was hoping that you could shed some light on what encryption is, what it means to developers, and how we implement it in our platform.
Sure, that's a great question. So typically encryption, typically people understand encryption in the sense that, sorry for my dog chewing food in the background. We're all at home. People typically understand encryption in the sense that it makes it so that your files can't be read without having some way of decrypting the files, and that involves having a key. But the question really comes down to who has the keys? Where are the keys stored? And could someone get a copy of the keys? Could someone get their hands on the keys and encrypt or decrypt your data for you? In a lot of services that offer encryption, specifically a lot of the existing cloud object storage providers, the default is encrypted storage, but the key is managed by the company that's storing the data. And when you interact with that service, the data that you're sending to and from them is decrypted, and then they store it, they encrypt it on their side with keys they manage. And so really that means that, you don't, it's only a little bit better than not having it encrypted at all. You don't really have any control over the data in transit. You don't really have any control over what happens if the company changes their business practices, if they decide they want to sell your data. Encrypted data where you don't manage the keys is just another way of adding a checkbox that's checked that makes you feel secure, but potentially isn't doing as much as you'd think. So end-to-end encryption is the idea that only you and only the person on the other end of the communication that you're sending data to, and potentially that's also you again, are the only people that have the encryption keys. And there's a lot of trade-offs to that, right? Like end-to-end encryption is sometimes not very user-friendly. You can sort of see this in terms of how Signal, the secure text messaging app, has been dealing with, recovering your information when your phone, you get a new phone, right? Like all of your safety numbers change with Signal, and you don't necessarily get the same history of all your messages. If you have cloud-based encryption, where the service manages your keys, you can do password recovery. You can do all sorts of different neat features to be able to browse and your content through a web browser, because the server is doing a lot of decryption in those things. The mechanisms to make end-to-end encryption user-friendly are very challenging. For us, one of the ways that comes down to is, so storage is end-to-end encrypted. The user who's uploading the data chooses who gets the keys, and our service doesn't get the decryption keys. One benefit of that is that we can't be compromised in a way that will decrypt your data. But the downside is, if you lose your key, we can't help you. And from a user interface perspective, our web interface, without a significant higher level of client-side application support than we have, the web interface can't show your files to you. Because the web interface is being hosted by our server, and our server doesn't have the keys to decrypt your data. So some of these challenges are solvable for end-to-end encryption. Keybase and Signal are making great strides to making user-friendly, strong encryption tools, but they're hard, and not every company does them. A lot of companies take the shortcut of storing the keys and managing the keys themselves. So yeah, there's kind of interesting trade-offs. It often comes down to end-to-end encryption feels much more harsh and brittle, in the sense that, yeah, it's very unforgiving if you lose your keys. It's very unforgiving if you want certain functionality. You just can't do certain functionality with end-to-end encryption without some backflips. And so we've decided to make the trade-off of, the market is already saturated with people who are doing the trick of storing the key for you. We're providing strong end-to-end encryption where only you have access to your keys. That means that if you lose your key, we can't help you, but that also means that we can never be compromised in such a way We can never change our business practices. We can never decide to sell your data.
Right. Okay, so I'm hearing a couple of things. One is that handing off that piece to someone else instead of doing it yourself with end-to-end encryption, there's a trade-off that happens. In one case, you have complete control, but you also have complete responsibility. And for a lot of people, it's worth it to have that kind of control and security and that peace of mind. The second is that I'd like to unpack a little bit of what you said about the web interface, which maybe some people may not be familiar with. When you are going to upload to the platform, you encrypt it yourself on your own machine before it ever goes anywhere. That's pretty clear. And then you go ahead and you make your API key on the web interface, but then everything else you do is in the command line, right?
That's right.
Okay. So I just wanted to clarify that for anyone who has been interested in the platform but maybe hasn't got their hands on it and experimented with it yet, that the initial steps occur in a web browser. And it's specifically because we have these kinds of encryption considerations because we're not exposing them. Is that right?
Yeah. The sort of the sign up flow is you sign up through our web interface, the satellite web console, just like you would with S3, with Amazon or with Google Storage. You sign up through your web browser, you configure your access, but then you can't actually upload or download data. You can with Amazon and Google currently. You can upload and download data through your browser and browse the files that you have in your bucket. You can't do that with us. Our admin interface currently, without adding a significant level of JavaScript to do client-side encryption and decryption in your browser, something that we're considering for the future. But currently, all you can do is manage your access control for what objects you can actually interact with and manage your billing. But otherwise, if you actually want to interact with your files, you need to download and use our uplink software and provide that client-side uplink software your encryption keys so that you can actually interact with the files in a way that you'll be able to see what the paths are named and what the content actually is.
Okay, great. Different tools for different things. Mm-hmm. So we passed lightly over some different kinds of encryption and what their trade-offs are. Are there any things to spotlight within that or any specific terms that people should familiarize themselves with? What are some of the key concepts that they should be aware of?
Sure, yeah. The major thing that we do is we do sort of the most recent standard best practice for encryption, which is authenticated encryption. Our default configuration uses AES 256 GCM authenticated encryption. But we also have support in our code base that currently is not as tunable as we plan to make it, but we plan to make it so it'll also allow you to use the Daniel J. Bernstein secret box cipher set for doing encryption and decryption. And it is an open source project, so of course, if you believe that there is something we can do to improve our encryption or add something in addition for your encryption needs, we certainly would be interested in pull requests. The major things that we're doing for encryption in sort of the architecture of our system is all data, every time you upload an object, we choose an encryption key for that object on the client side under your control purely at random. That encryption key is chosen cryptographically randomly. And what that allows us to do is to make sure that there's no sort of connection between how an object gets uploaded and really anything else. So we choose a random encryption key for your data and store the data encrypted with that key into the network. And then the metadata about where we put your file, where we sprinkled the encrypted grains of sand, to use a metaphor, keeping track of where we put it and keeping track of that random key, we then use that data and we encrypt it with data chosen based on a hierarchically deterministic encryption mechanism. Our hierarchical deterministic encryption is similar to what Bitcoin uses for hierarchical wallets. It's not quite the same though, because we have paths and I think BIP32 or whatever protocol, I don't remember the exact number, of hierarchical wallet encryption and key derivation is based on numbers. So we have a hierarchical derivation for paths. So what that means is it allows you to share sub-trees, sub-prefixes of the data that you've uploaded into a bucket and give someone access to some small amount of your data to be able to decrypt it without necessarily giving them the keys for everything in your bucket. So we have a rich access control and sharing mechanism that allows you to sort of break down areas of your bucket into smaller sections, and then you can just share those. You can just share a file. You can just share a folder. And they're not technically folders. They're actually, since we're matching the S3 API, they're actually prefixes delimited with forward slashes for our encryption needs. But we actually have keys and prefixes, and there isn't really a concept of folders, but can sort of mimic it with the prefixes. We support internally secret box. We by default support AES GCM. One trade-off of having all of your paths and your file names encrypted is that our system doesn't list your files in alphabetical order. It lists them in order of what the encrypted path names were sorted by. And so one of the options that we're considering sort of re-exposing is allowing users to, if they choose, to not encrypt their paths so that they can get paths in alphabetical order if that's a more important need to them. But we want to make sure that the default and the easiest thing to do with our system is to have all of your path and file data remain encrypted.
What are some other important terms for people to be familiar with?
Yeah, I think that there's a couple of different things that you can do. I mentioned authenticated encryption. So when people talk about, SHA-256 hashes, those are a way of taking data and breaking it into sort of a fingerprint, a signature of that data in a way that's irreversible. You can't go backwards. So we take hashes of a lot of data to make sure that the data doesn't change while it is in flight, while it is stored. We're very good at being able to authenticate from a cryptographic perspective that the data that you stored with us is the data that you're getting back. And we do that through SHA-256. And then, like I mentioned, our encryption is the AES 256 GCM authenticated encryption. And what that means is it's a best practice for how to encrypt data in a way that includes these hashes, so that the hashes are part of the decryption step, so that decryption fails if the data is slightly adjusted or incorrect. And the reason why that's important is because many of the encryption ciphers, and this is actually part of the thing ongoing with Zoom, there's a lot of questions going on about Zoom's own practices with cryptography and security. Zoom uses the ECB cipher mode, which, without going into some of the other details about that, doesn't have authentication as part of it. So if you decrypt data in one of these other cipher modes, you can actually just get back garbage. And so we're making sure that the data that you get back is the data that you put there, and that it fails to decrypt if something got tampered with. There's lots of tamper evidence seals basically in all the data that gets stored. And then in terms of how that all impacts, we also talk a lot about erasure coding and ReedSolomon. And it's worth pointing out that those are actually not encryption mechanisms. It's important that we do encryption first. And then with the encrypted data that we have, then we use the erasure code, ReedSolomon, that we're using to make sure that we're able to reliably break that data up, store it on lots of different nodes, and then reconstitute it once we have some of the original pieces that we stored back. So ReedSolomon allows us to have a really interesting property, which is, let's say our ReedSolomon code is, we configure it to be 2040 or something. I think right now in production we're using 2980. What that means is for any 80 pieces that we store, we only need 29 of them to get the data back. And then because the data that we used with ReedSolomon was authenticated with used authenticated encryption, once we reconstitute the data, just the act of decrypting it confirms that the data that we got back is exactly the data that was stored.
How widely is ReedSolomon used?
ReedSolomon is actually an old algorithm. It's used in CDs. It's the reason why when you scratch a CD, your CD will actually keep working. It's used in satellite communication. It's used like real satellite not like things orbiting the planet. Use ReedSolomon to make sure that the data that's transmitted to them isn't lost. So yeah, ReedSolomon is old. There are some other erasure codes that have interesting properties that actually just came out of patent protection that may be worth pursuing. I think if people have heard of tornado codes or some of these other things, there's more recent techniques on the table. We're using ReedSolomon mainly because it's well understood, it's fast, it definitely solves our problems in a good way. And we actually have a library. Not every ReedSolomon library supports actually doing error correction. where if some of the pieces are slightly corrupted, ReedSolomon is actually able to detect and correct those pieces. And our ReedSolomon library that we're using for Go was written by one of our employees that figured out the Berlekamp-Welch error correction algorithm. And I don't know of many other libraries that implement that in a way that allows us to do error recovery. Many of the ReedSolomon libraries essentially just assume that there are no errors in any of the reconstituted pieces and hope for the best, with the expectation that you've probably done some hashing of your own to confirm that the pieces were accurate before you even did that. We do sort of a best of both worlds approach. This is kind of how we do audits. This is how we do recovery and restore. It's a neat trick.
Cool. Okay. Tell me something that surprises people about end-to-end encryption.
Yeah, I think ultimately, whenever I've worked with people about end-to-end encryption, it really comes down to, I've often worked a lot with people who are trying to use end-to-end encrypted products, and it's sort of surprising the amount of functionality and features that are impacted by the decision to use end-to-end encryption. I've worked with people before who, we were at a previous company storing data in an end-to-end encrypted manner, and one of the pieces of data that was getting stored was pictures. And the question that this person had was, well, we're having trouble. We want to show the user all these pictures in a web browser. Can we just generate thumbnails real quick? And it turns out, oh, no, actually, you can't just go generate thumbnails. You can't just, if this was WordPress, sure, we could make a little thumbnail generation feature. But because this is end-to-end encrypted, it's a lot harder. You need to get the user to opt in. You need the user's client software to generate the thumbnails. We can't just do it on the server side. There's a lot of really interesting trade-offs in terms of usability, functionality, and security that get really intertangled. It's not the case that it's impossible to build a really user-friendly product that has end-to-end encryption, but just sort of reading some of the experience reports about how, for instance, Signal is going about some of their persistence of the social network of users using Signal is really eye-opening in terms of just kind of how hard some of these problems are. So it really comes down, when people are often surprised about end-to-end encryption, it's really just about, wait, why is this simple thing so hard? And it really, if it's a product decision to do end-to-end encryption, you just have to jump into it with both eyes wide open about, okay, this is a trade-off we're making. There are going to be greater challenges from a technical perspective, but if you're got the appetite to solve them, they can be really fun.
So I'm hearing a lot of talk about trade-offs and considerations. How important is it to make that decision up front about how you're handling encryption? Is it something that needs to be factored in before you start a project? Is it something that, because I think that a lot of developers really just, we need to get something done. We need to get something up and running and happening. And to be honest, encryption and security are just not always front of mind at that, like the urgency is to get something done. So does that lead to situations where you hit a point where it's too late to implement these things? How do you factor that in when weighing it against real world considerations?
Yeah, that's a really great question. I think especially when it comes to something like end-to-end encryption, it is really hard to bake in after. By the time that you already have a shipping product, you probably have users depending on features that are the sorts of features that would not necessarily be that easy to implement. So, to your point, it's really important that this is something that you think about heavily at the architectural level before you get started. It's not really something to bake in after. What's interesting about data center-based cloud object storage is it's really easy to punt on this problem. Because you manage all the servers, you have this problem where you can just not worry about encryption right away because you manage all the servers. You're storing the people's data. They can trust you. If they trust you, then it's sort of up to you to sort of secure your perimeter. In a decentralized or distributed storage product like ours, you don't have that choice. There's no perimeter to defend. Since everything is split up, you have absolutely no choice other than to solve strong security and strong encryption from the absolute get-go. It's just table stakes. And so it's sort of interesting, but in a way, having your data get spread across a lot of different storage nodes actually creates a sort of a harsher environment for a product to succeed in. And because of that, I think that products that actually work at all are much likely, there's a much higher bar and are much more likely to be much more secure. You can't take shortcuts. And so, once you get the initial sort of proofed out testing of your decentralized storage application, the fact that your data is resting potentially under people's beds as opposed to in a lockdown data center means that your data from a electronic level, from a network level, is actually probably safer. So it's just an interesting sort of distinction about how we don't get the choice of just doing perimeter defense only. We have to make every fundamental level of our system be secure all the way throughout the system if this is going to work at all. It's sort of an all or nothing table stakes type thing to make sure that you have really strong encryption. I'd be much more surprised to see data in an end-to-end encrypted decentralized product get leaked or lost than data from a cloud operator. All you have to do is penetrate the perimeter. And once you're inside the data center, if they don't have good security in there, if you can get to the server, the data center managed, provider managed keys, you have access to probably a lot more than just one user's data.
Okay, cool. So I think that sort of reflects some shifts in attitudes towards security that we've already seen unfolding over the years. I mean, if you look back to the 1990s, you used to see websites were secured with like a JavaScript password. I don't know, do you remember that? And you could view source.
Yes, yes.
Yeah. And things have come a long way since then. But I think that decentralization is really sort of heralding in like yet another kind of new, I don't want to say new era because that sounds like too jargony, but it is definitely like a different level and a different phase. And each of these new phases brings with it different assumptions and different attitudes towards security. Even regular lay people now have very different attitudes towards, how they handle passwords or how they think of backing things up to where we were, 10 years, 5 years, 3 years ago. What do you think the evolution to a new norm is going to look like as things like tardigrade keep spreading and become more and more mainstream as more people are using them? Do you think expectations around security and privacy are shifting in predictable ways?
Yeah, I think so. I think that, some predictable and some not. Google has been pushing, going back to sort of this concept about perimeter defense versus other defense. Companies for a long time have relied on VPNs to sort of secure their employees and their internal data. There's been sort of a growing push to rethink that model. Google pushed their Beyond Corp project, which was basically an effort to standardize on security models where you're not just relying on a perimeter VPN for your security. And you've also seen a lot of people start advocating for password managers or security keys or two-factor authentication. And the idea here, the reason why you do two-factor authentication at all is because you want to make sure that because there's this sort of growing surface area of how many of your things might be able to be attacked from some hacker nowhere near where you're living. People have this sort of like strong idea of locality. Well, none of my neighbors are going to want to get into my email, so it's fine. And that works, for your garage door. But the truth is there's 7 billion people on the planet, and with everything connected to the internet, all 7 billion of those people, if they had internet access, could be attempting to get into your account. And so the security properties of kind of, having these like simple walls continues to get more and more complicated. People are setting up two-factor authentication. People are stopping using VPNs. People are starting to think a lot more about peer-to-peer communication versus just sort of how secure you are at a server. And so I think sort of in the long-term view, I do think that things are moving more in a inherently decentralized security mindset, even if it's the case that everyone is working for the same company and it's not actually a decentralized product that you're working on. Even just this most recent global disaster that we find ourselves in has pushed a lot of people towards remote work, and people aren't in offices. And to be honest, I don't think that the push for remote work is likely to immediately go away once some of these pandemic curves are flattened. I think remote work is growing and here to stay. And so as people move more and more to these sort of decentralized roles, even within large companies, I think we're going to see a lot more focus on uh, uh, decentralized encryption, focused on securing your own personal devices, not having these sort of like safe networks, kind of the assumption that everything could be unsafe, and not just worrying about. It's sort of the same exact transition that you mentioned about. Yeah, people didn't expect that you could view source in your 1990s JavaScript guest book and find the password. And so that was totally a reasonable thing to do. The step after that was people started hashing their passwords in their JavaScript code, but that doesn't actually protect the web endpoints at all, right? So like the same sort of transition is happening, is that we're realizing more and more security has to be baked in at the beginning into everything, and you can't cut a corner and put a fence around something.
Thanks so much. This has been a really interesting talk. Any last words before we sign off?
No, thank you for it seems like the sort of thing I could talk about for a while. It's an exciting topic. It's really fun getting to work at Storj Labs specifically, because I feel like this is the type of product and the type of problem that is at the forefront of these issues. Being a decentralized storage product, obviously having world-class security is table stakes for us. And so it's exciting to get to work on that, and it's exciting to sort of push the envelope.
Okay, thanks, JT. It's been great, and I look forward to speaking with you again.
Yeah, thanks. You too, Jocelyn.
Take care.
You too.
And for everybody listening, thank you so much for listening all the way through. We push out content every week that is geared towards developers, and there are deep dives, tutorials, and other material that we think that you would like. If you liked this video, please like, share, and consider subscribing. If you have ideas on how it could have been better, please reach out to me. My email address is jocelyn@storj.io. And as the community manager, I would not complete the video without saying, please come and check out our community area. It's at forum.storj.io, and you can find really great conversations and all kinds of information there. You can also check out our comprehensive documentation if you want to get your hands on the platform, and go ahead and sign up for a developer account or as a storage node operator. The URLs are all in the description box below. Thanks, and see you next time.